Okay, question number 2, or rather question number 3. In the diagram, P and K are the endpoints of a diameter of a cycle with center M. S and R are respectively the x and y intercept of the tangent to the cycle at P. Theta is the inclination of PK with the positive x-axis. Okay, with the positive x-axis, so going that side. Now, question number 1. Determine the gradient of SR. So the gradient of SR, this line segment SR, and we only have one point in that line. However, we know that it is a tangent, and we know, what do we know about the gradients of a tangent and the diameter? The product of their gradients, there is a MSR multiplied by MPK. The product of their gradients should be -1. So we've got two unknowns. However, we can find the gradient of this diameter. We can look for the gradient of PK. We can just say -3 minus 5 divided by 0 minus -4. So it's going to be +4. -8 divided by 4, that's -2. So now we can substitute in -2 is equals to -1, and then this is multiplied by MSR. Let's divide both sides by -2. We should find our gradient for SR is equals to a +1/2. Question number 1.2. Determine the equation of SR in the form of y is equals to mx plus c. So we know what the gradient is. It's a +1/2, and we have one coordinate that we can use to calculate this equation. We'll use our coordinate P. So let me use a different colored pen. I'll use the blue pen for question number 1.2. So I'll use the equation y minus y1, and for my y1 I'll substitute in the value 5, and then I know what my gradient is. That's half x minus my x1, which is -4. So minus minus, it's going to be +4. Now let me simplify. We'll have half x plus 2 transpose -5 to the other side. It's going to be +5. Now for our equation, we have half x plus 7. So that's the half x plus 7. That's what defines that line SR. Question number 1.3. Determine the equation of the cycle in the form of x minus a all square plus, okay, that general equation of a cycle. So in this case, we need to know the center of this cycle. And fortunately, we are given 2 points, so we can find the midpoint of P and K to find M. Let us do it here. The midpoint of PK. So let me start with my x's. So -4 plus 0 all divided by 2, and then for my y we'll say 5 plus -3, all of that divided by 2. So this will be -4 divided by 2, that's -2. That's 2 divided by 2. So this is our center. At M we have -2 and 1. Now let's find at least our radius. We can use this distance or this distance. Either one you choose, we should find the same value of R. So in my case, I'll select MK. So for R square, I'll use the distance of mk. Let's say negative 2 minus 0 all square plus positive 1 minus minus 3, it's going to be plus 3 all square. So we'll have negative 2 square, that's going to be 4 plus 4 square, that's 16. So our r square is equals to the value 20. Now we can come and rewrite our equation of the cycle. We know what our value is, we know what our value of b is, and we know what our r is. And in the case of a, our value of a is negative, so therefore we need to be careful when we substitute in our a. So it's going to be minus minus, so therefore it's plus 2 all square. And then for y, we'll just say y minus 1 all square, and then our r square is given by the value 20, and that's our equation of this cycle. Now question number 1.4, determine the size of the angle PKR. There's our r there, PKR. So we are required to find this angle. This angle, the right there. So to find PKR, let us leverage what theta is. So at this point we don't know what theta is, but we can use theta, because in this bigger triangle we cannot use, since we know that the triangle PKR is indeed a right angle triangle. However, there's a lot of missing information for us to try and use our trig ratios. We don't know what the side of this distance rather, and let's not even attempt to use that method. Let's try and leverage using this angle theta here, or rather let us use this smaller triangle. Let's highlight it using the green pen. We have a smaller triangle here, and even this small triangle, it's a right angled triangle. However, there's more info because we are given theta here, and that angle theta, it's also this angle right here. Our angle theta is also this angle right here, because these two angles are vertically opposite angles, so they are equal. If we can find what theta is, we can be able to use the definition that says the external angle of a triangle is equal to the sum of the interior opposite angles. That means we can say theta is equals to this angle and that angle, 90 degrees plus PKR. And how do we find theta? Theta is the angle of inclination of PK. So to find theta, we can use m tan theta. We know what the gradient of this diameter is. It's negative 2, right? So we can say since it's negative 2, so negative just tells us our reference angle. So we can say 180 minus, what's our arctan negative 2? Or rather arctan 2. We'll get 63.434, and then I'll say 180 minus 63.434. 180 minus answer. Our theta is equals to 116. I'll round off to 2 decimal places, 0.57 degrees. Let me clean that up. And now let us go back to this equation. We know what theta is, so we can easily find what pkr is. So pkr is theta, which is 116.57 minus 90. So in my case, I'll just say answer minus 90. We get our pkr as 26.57, rounded off to 2 decimal places. Now coming to question number 2. Determine the values of t such that the line y is equals to half x plus t cuts the circle at 2 different points. Okay. So we are given a general straight line graph. However, there's a variable that is not constant, rather. There's a dynamic variable t that should be restricted in order for to say this line cuts the circle at two points. So what are the values of t that meet that requirement? Okay. So all our straight line graphs that have a gradient of half, meaning all of our straight line graphs will be parallel to this function. As long as a function has a gradient of half, they will be parallel. And only functions that are below this one will cut at least this circle twice. But the moment we arrive at this point, our straight line function with a gradient of half and some value t will only touch this function once, meaning it will form a tangent, right? Only once its value of t is -3, because at this point we have a straight line graph that is defined by half x plus the value of t should be -3. So -3, what am I doing? So that's our value of t for this last line. However, okay, this line does not satisfy our requirement because it's supposed to cut it twice. So that means our tangents are not included. Okay, so the simple solution to this is to say, as long as a function has that gradient half, but the value of t should be greater than -3, because once it's -3, that means that line is a tangent and it touches once. So that is why I'm not including -3. And the value t should be below the y-intercept of that line is given by +7, so t should be less than the value 7. So these values of t do meet the requirement of this question. Now question number 3. Calculate the area of triangle SMK. Do we have SMK here? The area of SMK. Okay. SMK. Okay, let me erase these things. Okay, SMK. Now let's construct a triangle that is called SMK. And do we know our coordinates here? So at S we have values. Our x is equal, okay, our y is 0, and what's our x? We can use that function. So let us say y is 0, Let's let our y 0, we'll get negative 7, and then x divided by 2. So we've got negative 14 here. And then we do know the coordinates of the center, and we're required to find the area of this triangle SMK. And we cannot use the equation half base times height, because in this case we don't have a right angled triangle, or we cannot easily define what our height is and which one our base is. So my go-to method that I like to run away to whenever I'm faced with a triangle like this and I want to find an area of a triangle, I just run to the cosine method. So we can use the cosine method, right, to find at least one of these sides, and then we can say our area of triangle SMK, we can say it's half, half height, or rather we can select at least two sides and then multiply by sine at least one angle. Let's see. In this case we cannot even use our theta. Okay. Yeah, so the only way I see it, for us to find the area of this triangle, it's either we say half multiplied by at least our two sides of this triangle, let's say BC, and the sine of the angle between B and C, sine A. So for example, let us name this side. Let us say that's our A, and that's our B, this line, and then this is our C. So to find the area of this triangle, we can use this formula, which is half BC, in this case BC, and then the sine of the angle between BC, it's this angle PKR. No, not PKR. PKS. So let me name that uppercase A, since it's facing smaller case A, and then this angle will be uppercase B, and then that angle will be uppercase C. Let me highlight my angles like that. So we can use this formula to find the area of this triangle, or we can rewrite that as AC and the sine of AC, the sine of B. Similarly, half AC, do we have AC, BC, BA, okay, half BA, and the sine of the angle between B and A, that's sine C. So we can use either one of these formula to find the area of this triangle. But first, let us determine our sides. So we need to only select two sides in this case. So either we work with angle C or angle B or angle A. Okay, in my case I will choose to work with angle A and B. No, with sides A and C. Yeah, sounds okay. A and C doesn't sound. Yeah, okay, it's fine. A and C it is. So let us find the distance of A. Distance of A is given by negative 14. That's it's going to be a huge number, but it's fine. Negative 14 minus, okay, it's plus 2 all square plus it's now 0 minus 1, which is just 1 square, and then this is my distance of A. Now let me find my distance of C. Negative 14 again. Just 14 minus 0 all square plus 0 minus or plus 3 all square. I'll find my distance of, do not forget to apply the square root because we are finding the distances here. So let me begin by minus 1 4 plus 2 all square plus, okay, it doesn't matter, 1 square. So for my a, I'm getting square root of 145. And then for my second, or rather c, I'm getting the square root of 205. And now we need to know what our angle B is. Okay, how do you find our angle B? Do we know what our distance of B is? Okay, let us also find our distance of B so that we can use the cosine rule to find this angle B, and then we'll be able to use AC to use that equation to find the area of our triangle. Why am I saying D? That's supposed to be B. So B, our distance of B, minus 2 minus 0 all square plus 1 plus 3 all square negative 2. So I'm getting 2 square root 5. Now our cosine rule to find our angle of A, our cosine rule, let me just pause the recording a bit, there's noise. One, two, one, two. Okay, excuse me, I had to mute myself there. There was a lot of background noise. So using our cosine rule, we'll use our cosine rule to find what the angle B is. So let us make cosine B our subject of the formula. We know what our B is, what our A and C, we have all of that. So we'll say B square minus A square minus C square. Or rather, since we have a negative there, we can just rewrite that as A plus B minus A plus C square minus our B square, all of that divided by 2AC is equals to cosine B. And then let us do our substitution, and then we'll do our arc cosine B to find the angle. So plus all squared divided by 2AC, what is A? Square root 145 multiplied by square root 205, 145, 205. Minus b squared. What is b squared? It's 2 root 5. Okay, I'm getting a decimal value for my expression on the left. So on the left I've got 0.9570. So I'll just do the arc cosine of that. Arc cosine answer. I get B as the angle of 16.858. Now we know what our B is. We can come and use this equation. So we'll just say half our value of A is given by square root 145 multiplied by C. What is C? Square root of 205. And then we have sine. In my case, I'll just say sine of the answer. So 16.858. So I'll just say half sine of the answer (205). Let's see. Interesting. I'm getting a perfect 25. So the area of this triangle is equals to 25 some units squared. So units squared, 25 units squared. Okay, yeah, you can double check by using maybe your other sides, B and C, or if ever you've got a much easier way of finding the area of this triangle without going through the cosine rule, please do send us a text on the comment section of this video. Thank you. Okay.